Hi, my name is Bordei, and in this video I want to talk a bit about VMs and containers and in their respective intelligent placement, right, within a particular host. I know MetalSoft is known for bare metal management, but for those of you who don't know, we actually do VMs and containers as well, right? But we do it with our own unique bare metal twist, right? And so what that means is that when we provision these VMs, we don't just provision them at random. We use the knowledge that we have about the physical server and the topology of the server and the topology of the physical network to make intelligent decisions about where we place things. Right? This is, may not be very important for normal VMs, even though it's important for those as well. But it is absolutely important for GPU workloads, right, and AI workloads in general, where you need GPU to GPU communication at times, right, if you have a big model. And so how does that work? Right? This is something that happens under the hood, right? So this is not something that you have to concern yourself with. But I still think it's very interesting, and I want to talk a bit about it, right? For those of you who are interested in this kind of stuff, stick around. So let's say I'm a service provider and I have a customer coming to me and issuing an API request and saying, I want a VM with 2 GPUs, right? Of AMD or NVIDIA GPUs, right? And so now MetalSoft under the hood manages all the hosts that have all these GPUs and the interconnects, the fast and interconnects between them, InfiniBand and Internet interconnects, right? And so inside a particular server, you have GPUs connected to PCI Express, connected to CPUs, but you also have, or you can have in certain cases, DPUs. Right? These DPUs are, for those of you who don't know, smart NICs that are able to terminate layer 2 broadcast domains and offload VXLAN encapsulation, for example, and set up BGP sessions. And they can also do firewall offloading. They can do storage offloading, like NVMe over Fabric offloading, and so forth. Right. So they are increasingly, present in hardware for AI infrastructure, especially multi-tenant environments. Right. And there's also obviously some hosts have NVLinks to interconnect the respective GPUs. The NVIDIA ones have. And so how does MetalSoft provision a particular VM? Right. So when the request comes, we search for the NUMA node that has the requested number of GPUs available, right? Not allocated to any other VM. Right? So let's say NUMA 1 has 2 GPUs available, right? So we're going to allocate this NUMA node. We're going to instantiate the VM on it, VM1. Right, and in that case, we also allocate GPU 1 and GPU 2 to the respective VM, right? And they will pop up inside the VM. You will see 2 GPUs. And at the same time, obviously, the customer doesn't just want a VM, isolated from anything. It will say, oh, I want it connected to this network and this other network, these logical networks that are private to the respective tenant, and so they are isolated from each other in their own little VLANs, right? And I want the respective VMs need to be able to talk to the bare metal networks. If you may remember that this is a particularity of MetalSoft that we use bare metal networks instead of overlay networks, right? That makes them very, very fast and also allows you to connect VMs to bare metal servers, with no issue, even though it's a multi-tenant environment. And so for this particular VM, let's say we terminate VLAN 100. Could be VNI 100 for EVPN networks. And we terminate it onto the DPU. Right? The DPU will then present inside the operating system a virtual function, VF, right? And we will map that virtual function to the respective VM. So inside the VM, you see just a regular NIC with an IP, and that's it. If you do a broadcast, you will only do the broadcast within your particular VLAN, right? But from a performance perspective, this will offload all your traffic, and there's no encapsulation, overhead in any way, right? It's similar to how we do it with the physical switches when we do bridges, but the complexity is actually lower and performance is higher, and it allows you to do for a firewall, distributed firewall on it. But anyway, coming back to this, so now I have a VM that's functioning. Now, so this is true for all of the hosts that don't have NVLinks for interconnect the GPU. So for example, RTX hosts, right? But DGXs and similar hosts, they have NVLinks, and the NVLinks will interconnect every GPU with every other GPU within the host. So you can have 12 chips, NVLink chips, and all of the GPUs will be connected to all of the 12 GPU NVLink chips, right? And so you will think, okay, well, it's very easy, I don't need to do anything, but you still need to, even though the GPU to GPU communication will no longer traverse the PCI Express bus, you still have the loading and unloading of data to and from the GPU. So for example, your source image or your text or whatever you have, there's still communication between the CPU and the GPU, so you still need to make sure that the numal node placement is correct. And also, if you have NVLinks, you also need to be able to partition the NVLink so that the VM does not use the NVLink to see other people's GPUs, right? And so there's partitioning that happens within the NVLink when this VM gets created. So note that at the time of the recording of this video, the NVLink part is still under development. We hope to have it ready in 7.5. But everything else that I've talked about is already available in 7.4, so you can test it out. Right. And as I mentioned before, VMs are very, very similar to containers. And so the allocation mechanism is very simple. Right. So thank you for sticking with me for a relatively long amount of time. I hope you found this interesting. Thank you for watching.